Good morning, guys, of grade 8. Today, inshallah, we're going to continue lesson 3 of chapter 13. We're still talking about the acids and base. So, last time we know the difference between acid and base, and we said both are types of solution, but they have a special characteristics that the acid it's a substance that dissociate in water or just break in water and release hydrogen ion that is gonna combine with the water producing hydronium ion, which cause the acidity or the properties of acid. While the base, the other face of the coin, as we said, it's the opposite. It's a substance that dissociate or break down in water, releasing hydroxide ion, which cause the properties of the base. Today we're going to continue our lesson. So we're going to talk about something called the pH. So what is a pH? Actually, pH is just a kind of measurement tool or measurement method to know, okay, this substance is acid or the base. So here we said that the pH is an inverse measure of the concentration of hydronium ions. That means it's somehow a way to know how much hydronium ion are available in a solution. And regarding to the amount of the hydronium ion, we could determine this solution is acid or base. The more hydronium ion available in the solution, it means it's acid, and the less hydronium ions found in the solution, that is base. So here we find this like this a solution with lower pH. Okay, that means the number of pH is low. It will be more acid because as you could see here, we said inverse measure. That means the less the number, the more acidity is because it's inverse. So here we find this regarding to that. As we could see here, the scale of the pH, it's just a scale like graduated from 0 up to 14. So here we could find the 7 is neutral. That means if the pH equals 7, in that case, the concentration of hydronium ion will equal to the concentration of hydroxide ion that's at pH 7. Like in water, water is a neutral. Why water is neutral? Because we're actually the amount of hydrogen ions equal the amount of hydroxide ions. So in that case, it's neutral. Also, normal salts, okay, they are once they break down in water, they are neutral because there is no, okay, or hydronium ions are free or hydroxide ion are free, so it's still neutral. But here we find that less than 7, once the number decreases, okay, than 7. So we're gonna find the concentration of hydronium ion increases while the concentration of hydroxide ion decreases. So it's be acid. So we could observe that pH, okay, 1 or 0, 0.1, 0.2 up to 7, as we can see, that means the stronger they are acids. So here that means as we move toward the 0, the acidity increases, okay, which means that will be a stronger acid. While here the opposite in the other side, as we move toward the 14, okay, the we said that a basic effect increases, okay, and the acidity decreases, which means the strongest acid it's near to 0, while the strongest base near to 14. Okay, so like this here. So we just could write it like this, okay, like this. Okay, we said that acidity increases. Okay, would that mean, for example, if I said that you have two solution, the first one it's pH equal 2, okay, and another solution it's pH equal 9. So in that case, pH 2 means it's from in that area, so it will be an acid, okay, while that's pH 9, that means it's more than 7 up to 14, so it will be base, so that is acid and that is base. That's how we could determine, okay, or that's how we could differentiate between the acids and base, okay, regarding to the pH. As we move toward the 4 here, we said that base strength increase, okay. So in that case, if I just tell you, okay, for example, if you have two solutions, one pH 2 and the other one it's pH equal 5. So which one is the strongest acid? 2 or 5? Of course, 2. Because as we move toward the 0, the acidity increases. So here the pH 2 means it's stronger acid compared to the pH 5. While here, if you said that you have another one that's pH equal 13. So which one is the stronger base? The pH 13. Because as we know, we move toward the 14. Okay, the base increases. So like this, that's just like a scale that represents, okay, the acidity and the base effect of different solution. In this case, okay, we said it's an inverse measure of the hydronium ion, which means, okay, we calculate the amount of hydronium ions. So here, regarding to this part, okay, that's how we could find the difference between acid and base. But we still ask a very important question, and practically how we could measure it. Okay, so just look with me here, guys. So we ask here, we said, what is pH? So acid and base solutions contain both hydronium and hydroxide ion, as we said. So regarding to this, we calculate the amount of hydronium ion in natural solution like water. We said the concentration of hydronium ion equal to the hydroxide, so there is no acid or base. But once we have greater concentration of hydronium ion, that will be an acid, and if we have greater concentration of hydroxide ion, that will be base. As you can see here, that's what we explained. As we move forward toward the zero, the acidity increase. So you could observe that, for example, milk, it somehow a weak acid because it's near to the 7, while for example the stomach acid, the hydrochloric acid found in your, okay, stomach, it's very strong, or like soft drinks like Pepsi and something like this, vinegar, they are stronger acid than milk, okay, because their acidity is about 2.4, and as we move toward the 0, the acidity increase. In the other side, as we said, as we move toward 14, the base effect increase and become more basic, okay, so we could find them, for example, the seawater, okay, it's somehow base because it's range from 7 to, that means somehow it's neutral or a little base, okay. But for example, we could find the dream cleaner, okay, its base or its pH equal 13, which means it's stronger base and so on. So here, like this, guys, we said that how we could measure, okay, the pH, okay, or that's, we said that the pH scale is used to indicate how acidic or the basic of the solution. So we said that in that case, okay, in the lab, how could I detect? I know the scale, but how if I have just a beaker that contains a solution, how could I test that is base or acid? We have different ways to test this base or acid. Okay, we could have different things. First of all, we have something called the pH meter. pH meter actually is a tool or a device that we just put in the solution, okay, and it has a screen that is going to record exactly how much the pH. So if we just read a number, like for example 6 on the screen, it will refer that is a weak acid, okay. If we have reading about 12, that means it's a base, and so on. So pH to a pH meter is a device that is used to detect exactly how much the pH of a certain solution, which means it's an accurate tool to know, okay, what is the pH exactly of a certain solution, so we could determine is it weak or strong acid or weak or strong base. But we have another ways also that not accurate that much like the pH meter. They just ways that I could use to know is it acid or base, but actually the exact pH we can know it. For example, an indicator. What is indicator, guys? Actually, indicator, it's a substance that could change its color, okay, in different range of pH, which means it's differing, okay, or this it's a kind of substance that once it added to the acid, because of the presence of hydronium ion, it will lead to change in color to form a different color. Okay, for example, okay, the substance, the indicator, like some indicator like phenolphthalein, okay, once it added into base, it gives the color change into light blue, but once we added in okay acid, it's turned to be like red. So like this, it's a substance, it changes its color depend on the pH or depend on the type of the solution. It gives different color in acids and another color in base. So like this, I could use this kind of indicator to determine is it acid or base, but actually I don't know the exact pH of the solution. So here we said that there are many different indicators. Each indicator change color over a specific range of pH. Okay, the pH of a solution can be measured by dipping a pH testing strip into a solution. There is something called the pH testing strip. Actually, there are some strips, okay, paper strip, they have different, they change their color regarding to the pH. So also that's like, for example, also litmus paper, it's one of the technique or one of the strips, okay, that could help in detecting, okay, litmus paper, that we have red litmus paper and blue litmus paper, for example. The red one, once it's added into the acid, doesn't change color, but once we added into a base, it turned into red color. And the blue litmus paper, once we put it in base, doesn't affect it, its color, it's still blue, but once we put it in acid, it turns red. So here like this, that's how the change, or that's just some techniques I could use to know this solution is acid or base. But if you need to know the exact pH, it's better to use a pH meter because it will tell you exactly how much the pH. So like this, guys, we already end our lesson. Okay, we know what are the difference between acids and base, what are the characteristics of both of them, and what are the uses also. And finally, we know what is the pH and how we could measure the pH of different solutions. Please study this lesson very well from your textbook. And if you have any question, we are waiting for your questions. Thank you, guys, and goodbye.